Okay, this problem says refer to the accompanying scatter plot over here. Examine the pattern of all 10 points and subjectively determine whether there appears to be a strong correlation between x and y. Find the values of the correlation coefficient r, determine whether there is linear correlation, and then they want you to do some other activities with it. So let's do this first. Do they appear to have a strong linear correlation? Well, looks like we could just draw a line straight through there. So yes, they do. Okay, now they want us to find the correlation coefficient. So let's make this a little bit bigger. And we're going to have to set up over here, we're going to have to set this up. I'm going to put X right here, and I'm going to put Y right here. Now we're going to have to fill these in. This point right here has the coordinates of 1, 1. But how many dots do we have on 1? We've got 3 dots on 1. So I'm going to do 1, 1, 1. Then I've got 3 dots on 2. I'm going to do 2, 2, 2. And then we've got 3 dots on 3. So I'm going to do 3, 3, 3. And I have 1 dot on 9. Okay, now I'm going to go put the y values in. These all had the 1, but the y's are 1, 2, 3. So I'm going to say 1, 2, 3. And then for the 2's, 1, 2, 3. For the 3's, same thing. 1, 2, 3. Now, up here, this point is 9, 9. So its y value is 9. Okay, we've got the data points in now. Okay, we're going to go to Stat, and we want to go to Regression. We want simple linear. The x variable, we put it in x. The y variable, we put it in y. And we're going to do the hypothesis test here. Your intercepts, let's see what these are supposed to be. Okay, we'll leave all of this equal to 0 and not equal to 0. Let's compute, see what we get. All right, now, I think we've got what all we're supposed to get here. Okay, the R correlation coefficient, this is what we're looking for right here. And they want it to 3 decimal places, so that's 0.880. Okay, now it says, is there a linear correlation between these? Before you can make that decision, you need to know how many points you had. You had 10. We'll go to the critical value at the 0.05. That's 0.632. So 0.632 compared with 0.880. This is greater than from the chart. You want it greater than the chart. So is there correlation? Yes, because the correlation coefficient is in the critical region. Now, what they want you to do is to go in and remove the 0.99 that was right up here. So let's go to Options. Let's edit. But what do we have to do first? We want to come over here. Let's just go ahead and delete this because we're going to have to get to our chart here. Delete the 0.99. It's just that easy. Pretty easy to delete. Go to Stats, Regression, Simple Linear, Of course, our X was in the X, the Y was in the Y. And if you didn't label them X and Y, it would just be vars 1 and vars 2. Remember to leave these, all of the intercept and the slope for right now, you want those to be left at 0 as you're trying to figure this regression. Okay. What is your correlation coefficient now? It's 0. So 3 decimal places is still 0. And that's not greater than anything. Why does this happen? Because when you take that point out, the line of best fit is just a horizontal line. And if you remember from algebra, a horizontal line has a slope of 0. All right. Is there a good linear correlation? No, because the correlation coefficient's in it. No, because it's not in the critical region. Now, did that one pair, that one point right there, that pair of numbers have any effect? A single pair of values does not change. The effect from a single pair of values can change the conclusion. 1 point makes a difference.